just to open, if you started the exercise in the last class, please go ahead and open it. So until you open it, just I want to remind you of what we've been doing in the last class. In the last class, we went and we would like to see how Civil 3D can estimate some volume for us. And we have seen two methods. Method number one, it's called volume dashboard, which is you need to build two surfaces. And remember, you need two, not only one, two. And then if you need to edit them, great, go ahead and edit them to make them a good surface. Then as simple as here is surface number one, it's called the base surface. Here is surface number two, that's our comparison surface, and the software can find the volume for you. We discussed already that this method is kind of a good method. It's very accurate. However, has a little problem, and the little problem is this method is not convincing, which means if your boss asks you to find the volume and you just take a snapshot of the final results, they cannot believe you, because remember, there is a conflict of interest, and this turns into money, and you must be convincing. And so that's why we said, okay, let's look at another method. So we looked at another method called method of cross sections. And the method of cross section, it is something that we already discussed in our class, and we've done it manually, where if you're able to come up with cross sections across the ground and find the area of individual cross section, then we can use all the areas of the cross section into Simpson or trapezoidal to find the volume. So in the last class, what I did is I start to show you in details how do we use the cross-section area method to find the volume. And remember, the steps are, you need to build the two surfaces and edit them if required, and which was exactly the same what you need for the other method, which is called volume dashboard. For the cross-section method, you must create an alignment. And as I said, alignment is a terminology that probably you guys used in other class for road design. So you turn your road center line into an alignment, and you draw a profile or cross-section. And in this class here, we're not really designing a road, we're not designing a pipe. So what is the function of the alignment? It simply serves as a reference line. Once you have a reference line, then you can cut cross-section perpendicular to this reference line. So we have defined an alignment, which is what happened is I picked the alignment on the north side, going from the west to the east. And if you remember, and something I would like everybody to understand, that the location of the alignment, the orientation of the alignment, the direction of the alignment, all of those are your choice. In my demo here, I chose my alignment on the north side, going horizontal from the west to the east. Can you solve the same problem using different alignment? Yes, you can. For example, you can choose your alignment at the center or at the south. You can even turn your alignment vertical. The thing is, once you have a choice, everything, it will depend on your choice. If you remember, when I start cutting my sample lines, I needed to add a left swath and a right swath. Those numbers are totally dependent on your choice of your alignment. If you remember, when I chose my alignment on the north side, I need nothing on the left. Nothing on the left. You can see I asked for 0. And on the right, I went with 40 meter on the right. As I said, if you were to choose your alignment in the center, then you have to ask for 20 meter left and 20 meter right of the alignment. Bottom line is, your sample line, those lines are in blue, must at least cover the extent of your surface. You can go more, but you cannot go less. And if you don't remember why I cannot go less, and what does this mean? It means if I can click on my sample line, I'm asking you, if we take my sample line, go this way, good or bad? Any help? Is a mistake?
It should just be right within your boundaries, right?
Uh, that's the minimum. So the minimum is here. So the minimum is my sample line go until the boundary of my surface. But my question is, if I do it this way, I extend my cross section of my sample line beyond my surface extent. Is that a mistake?
It's not a mistake. It's just we don't need it. It's waste of.
Okay, yeah, you don't need it. It's going to waste a little bit of space on your paper, but it's not a mistake. The mistake is the opposite. If you make your sample line shorter than it should be, like this way, as I said, your section will come short. And we already did the demo. Huh? I'll show you on section number one. Why is that section number one? Because we already have a cross section for the first section. So I will simply click on the other section to remind everyone, and I will put them side by side. Watch this. So if I click here, and if I extend my sample line right of the alignment a little bit more, please see what happens to my cross section. You can see my cross section right now. It has an extra part. However, it doesn't affect your calculation because you can see there is no existing, there is no design in this area because your surface has ended here. Okay. However, the mistake is this. If I stretch my section and I go to this point, you can see what's the mistake. The mistake is my section is only 30-meter wide. My area calculation will be between the magenta and the blue, and anything beyond this point where I'm showing right now is simply will be ignored, will not be estimated, and that's why your area will be wrong, and consequently the volume will also be wrong. Okay, so I'm gonna return it back. Now, you can see right now, if you remember, I created some cross section. How many total? I have total of 5 sections and represented by those sample lines on the plan view. So what is the sample line? The sample line, it's kind of marking on your plan view where is your section and how much left and right of the alignment you want to extend your section. Okay, now what's next? Next is we are able last class on Friday to plot some of those sections. So we already plot some of them. You can plot them individually. Like remember, I already plot only one section last class, which is at 0, but I can simply plot all of them at the same time. So in today's class, what I will do is I will plot all of them. If you guys remember how to do that, we go from menu sections, and then you can see we have 2 options here. One is create a section view, that's a single one, or if you want to plot all of them, let's do that right now, create multiple section views. Here we go. So if you create multiple section views, you get this wizard here, which is simply you have to change some parameters. You go next, you change some parameters on the next item, which is section placement, and so on and so forth, until you finish, and then you say create section views. Now, before we start, let me remind you, a single civil 3D drawing may contain so many alignments. And that's why the first thing you want to do is make sure that you choose the right alignment. Luckily, in this drawing, we have only one. Here is my volume alignment. Also, remember that for a single alignment, you may end up with some different sample line groups. Like I said it already, if you're designing a road for, let's say, 30 kilometers, and those are built by a different contractor or contractors, you want to create a sample line group for every contractor. For example, a sample line group has all the sections from 0 to 10 kilometers. Another sample line group that has the sections from 10 to 20, and then the last one from 20 to 30. So please ensure that you choose the sample line group here. In our case here, we don't have this, so I have all the sections under the same sample line group called 0-40. Then also, if you want to change the station range, like let's say you want to plot from 0 to 30, then you can do that here. Right now it's automatic, so this will print everything. If you want to change this one to user specific, then you want to choose the first and the last cross section. I will leave it as automatic. Those setup is about how the section will look like. And again, if you're really creating a set of drawing, maybe you want to go here and then play with the style. For now, I will leave it as is. As I said, I'm done with this window here. So I'm going to go to next, and we'll simply look if I need to change some of those parameters or setup. This one here is about template. So when we printing so many sections, we print them into a title block. So right now, the title block, it's one of the standard title blocks for Civil 3D. And if you wish, you can go here and change it to any other title block you may have. Okay. Now, if you want to keep going, hey, next, there are more setup. To be honest, here is what I do. I always simply skip all those steps because the software, I leave it as automatic, and the software will control this on my behalf. Okay. So at any point of time, if you're sure that everything here is okay going forward, then you can say create section views. You know what? I'll go next. So I'm happy with all those setup. I'm happy with those setup. Those ones here, I'm happy with them. So next, and then finally, I will say create section views. And this time, when I click at any point on my screen, see what happens. It is going to print for me all the section at one shot. So you can see here is all my sections. On the top left here is my station 0. That's the first one. And then 10, 20, 30, and then 40, which is exactly how many sample lines I have. Please look at this. Count on the plan view how many. 1, 2, 3, 4, and 5. So I have 5 sample lines, and for every sample line, it simply gives me a section. Great. So what's the next step? So after you draw the cross section, I'm asking you, anybody can guess what is next step? I'm not asking you to tell me how on the software, but I'm asking you, what do you think, what should be the next step to find the volume? Any guess? And again, I'm not asking you to tell me hit menu this or no, not asking you. This is something I'll teach you, but I'm asking you, if you have this cross section, what you want to do for this cross section to find the volume? Any help?
Would we want to figure out the cross section area?
Thank you, sir. Perfect. I really appreciate your input. So what happens here is that, as I think you said, what happens is between the magenta line, which is the existing ground, and the blue, there is some cross-section area. We want to find this area. Are we going to do this manually? Am I going to draw here a polygon between the blue and the magenta and find the area? Not really, huh? So the software can do that for me, can find for me all the cross-section area. I'm going to show you right now how, but thank you so much, Adrian. Okay, so you want to go to find your cross-section area. You want to go from menu sections, and you go down to compute materials. You want to go from menu sections, you want to go compute materials. Okay, let's do that. So when you go compute material, before you start computing, the software will ask you, can you please choose for me which alignment? And you guys remember, in any Civil 3D, we may have so many alignments. Please ensure you check the right alignment. Number 2, for the same alignment, you may have more than one sample line group. In our case, we have only one sample line group. Then finally hit OK. And so this is the window that we're going to use to find the material. First thing you want to do is you drop this menu here, and then there are some called quantity takeoff criteria. Please make sure you choose earthworks. So that's number 1. Number 2 is on the method. So we have here a volume calculation method. If you drop this menu, we have 3 methods: an average end area method, a prismoidal method, and a composite volume method. In my class, I taught you 2 of them. Can anybody tell me which method did I teach you in class?
Prismoidal.
Sure. And which one? What's the next one?
Average area method.
Do you guys that I gave you a different name for average end area? Does anybody remembers what's the equivalent name of average end area? It was in the last class, by the way.
That's the trapezoidal method, is it not?
Yes, sir. Thank you so much. Yes. So the average end area, because remember, the trapezoidal does nothing more than taking an average, but do this quickly. So please think about this word, the average end area. It is your trapezoidal method, and this one is prismoidal, which simply finds your volume more accurately. Now, I know all of you will say right now, okay, Tahir, okay, let's push on prismoidal. Okay, I know all of you will say that, because we know that prismoidal will give us a better estimate. Yes or no? What do you think?
It should.
Yes, sir. However, what I will do, to be honest, I will use the average end area method, which is trapezoidal. And I know some of you will be surprised why Tahir is doing that. It's only for educational purpose, because simply when I plot my table, when I use average end area, it's easy for you to follow me and understand how the table is being formatted and built. But if I use prismoidal, you will get lost. Okay, so in your real life, you would use prismoidal. However, I use here average end area method just because I want to teach you how the numbers work in the table. Okay, we're very close, by the way. Now, next is you want to come here and then you want to choose which one is your existing ground and which one is your datum. Why this is important? Because you need to figure out the order. The order is important because if you reverse the order, simply you switch the cut and fill. Here is very simple. In the previous method, it says base and comparison, which means I give you the rule. Base is where you start, comparison is where you end. Here it's more simple. Existing ground, you drop this window. And what are those? What are those? Those are the available surfaces in my drawing. You could have 10, 20, 30, doesn't matter. Really, you want to choose your existing ground. So my existing ground is in AG, where I start, and then my datum is my design, where I end. Are you guys following?
Yep.
So 3 things: change quantity, take off earthworks, average end area, that's the method, and then choose the surfaces. And here we go. I'm going to move my window here because I want everyone to visually see. As I hit OK, there is something is going to happen here. I move my window, so all of you guys, please focus on the cross section, basically between the blue and the magenta. I'll hit OK. Please watch. Did anybody saw or see what happens for my section? All of them. Did you see what happened?
Yeah, they all got a fill.
Yes, sir. So what happens here is that the software did the area calculation and figure for me already all the cross-section area. This is something very important because please, when you do that yourself, please make sure that all the section got this thing. Otherwise, if for unknown reason, if the section, one of the sections has no hatch, it means the software failed to find the cross-section area. Okay, so that's why just take visually a quick check and ensure that all the cross-section area have been estimated. Now I'm asking you, now I know that we don't see the numbers, so I know that some of you will ask, so how much exactly the cross-section area at 0, at 10, at 20? Those are kept right now in the memory of the software. However, so you know, the software has already figured them out. Already, so we don't have to do any calculation further, okay? So we know the cross-section area. So our last step right now is to simply show those areas and the volume. Watch this. So our last step is you go from menu sections. We already computed the material. So finally, you go to add tables. We want to show the cross-section areas, how much exactly, and the total volume. So I go to menu sections, I go to add table, then I go to total volume. Let's do that. So I go total volume. We have here a window. We have to make sure that those parameters are correct. Let's go one by one. So number one is a style. And you guys remember by now, a style, it means colors, it means a font height, it means order. So you know what, as usual, I will take this style. I'll leave it because there's only one style here. If I need to change it, then I can change it in the future. Huh? Next is, we have to check and make sure which table, for which alignment are we creating a table. So you can see here, select alignment, you drop this window, it shows you all the alignment in this drawing. Make sure you choose the right alignment. Number two is, we know that for every alignment, there could be more than one sample line group. So please check if this is the right sample line group, okay? And then finally, if your alignment is too long, it means I have so many cross sections. This will create little problem when we create drawing, because simply my table will become so tall, so high, it doesn't fit into a drawing. We've seen this problem before when it comes to point tables. If you remember, probably a few weeks ago, when a month ago, when I was trying to show you how to create a table of points, if I have so many points, my table will be so tall. It doesn't fit into the drawing. So we have the option to split my table into smaller size table that they can easily fit into my drawing. So you can see here we have the same number. I can split my table into chunk of small tables of maximum 20 rows per table, and every 3 table will create a stack, and so on and so forth. You guys, probably some of you already remember this part here. Finally, the behavior, we already discussed this already with the tables for points. You can make the behavior static or you can make it dynamic. Any help? Which one should I choose?
You want it on dynamic so that if anything changes in the drawing, it should automatically update?
Thank you so much, sir. That's really what you have to do, because simply, as you said, dynamic is the best. If you need to cut more cross-section, if you change your sample line with anything, it will dynamically update your table. Otherwise, it will be just like a text. It will never be updated. Hit OK. Next is, so my table is here, and the software is asking me, could you please pick any point for me to draw your table? Here we go. Here is 1 point. And you can see, here is my table. So my table is here, and please count with me how many lines in my table. Is that obvious? How many? I get same number of my sample line, same number as my cross section. So for every sample line, I get 1 line on my table. 0, 10, 20, 30, 40. Okay? Now, there is one exercise we will do it before we simply show you the calculation in the table. As a student, I would recommend you highly to know, not just get the final number, you need to understand what each number means in the table. But I will do that later on. For now, let's take a check. I'm asking you, this number here, we got 4,018.75. 4,018.75. My question for you is, do we have a benchmark or reference for this number that we should compare against? Like, do we have a reference for this number, or should we just accept it?
Can't we check it with the volumes dashboard one that we did earlier?
Yes, sir. So here we go. So in order for me to bring up my dashboard again, you know what to do, huh? I'll go on my plan view. I click on my any surface. I go to volume dashboard. It will simply open for me my volume dashboard. You can still see here, huh? So here is my number from the volume dashboard, and here is my number from my cross section. I will let you guys enjoy, huh? Enjoy the comparison. Take your time and tell me, what is your observation? Are we getting the same number, or are we getting a different number, and why we're getting different number? Please take your time, a couple of minutes, please.
I believe for the one we did just now, it took into consideration where the building is. The previous one, we had our boundaries and we excluded that.
Thank you so much, sir. You know what? Every year I have hard time to kind of convince my students of what you exactly just said a minute ago. Like students, they don't get it. Why we're getting different number? For sure, the difference is huge. Huh? You can see there is about 600 cubic meter difference between whatever we get from the cross-section method and the volume dashboard. And again, if you want to also remember what we have done, or sorry, what's the number we got manually? So you guys remember, huh? The number we got manually is here. So this is the number manually. I'll open the file for you and put them side by side, everything together in one. Okay, so you have the three numbers side by side. A number that we got manually, 3,391, volume dashboard 30,415, using the cross-section area method is 4,018. So it looks like two methods. We already did this already. We kind of compare between the manual number and the volume dashboard. And we simply said that the volume dashboard is a little bit better because it uses triangle as a base pattern, unlike my manual method, which uses a square. Now, I think your Shimaz, your Shimaz, you said this number is different because of the building. Can you please confirm?
Yeah. Yes.
Okay, so I will try to explain for one why this is true, why or what happens here. So let's look at how the software calculates the volume first, and you will know the answer by default, I guess. Let's look at this. So the software here blindly. Now, once you as a user set where are the cross sections at 0, 10, 20, 30, and 40, and the software found the areas. Watch this. So this number here, for example, 111. This number here, 111, is simply the area of the cross section at 0. How about the 97.5? This is the cross section area at 10. Now, how the software will find the volume from 0 to 10? We already discussed this, by the way, and I want you, please, guys, if you want to get the benefits, get your calculator handy. Get ready with your calculator. So in order for you to find the volume between 0 and 10, not the entire volume, just from 0 and 10, we already know what to do. We've discussed it several times in our class. All you have to do is you take this number, you take those two numbers, like this number and this number, those two numbers, and what to do? What do you think? What to do with these numbers? So we have the cross-section area at 0, and we have the cross-section area at 10. I'm asking you what to do to find the volume in between 0 and 10. Okay, I'll help you out. So I'm asking you, what if we take 111 plus 97.5 divided by 2? This gives me an average area between 0 and 10. Then finally, multiply by the distance in between the section, which is 10 meters. Please, everyone, do it if you want to understand how this table works. 111 plus 97.5 divided by 2, then multiply by 10. Any help with the results?
1042.5.
Thank you. And you can see it very clearly here. Look at this. So here is the number you just got. So the cut volume from 0 to 10 is 1042.5. Please, let's do it one more time. How much the volume between 10 and 20? Okay, I'm gonna connect those sections, huh? How much the volume between 10 and 20? Any help? 97.5 plus 95.75 divided by 2, so an average area multiplied by 10 meters between section at 20 and section at 10. Please do it and let me know the answer.
966.25.
Which is here. Watch this, sir. Look at this. So the number between 10 and 20, not the entire volume, just the volume between station 10 and station 20, we got 96.25. What is more serious is that, watch this. So I'm asking you, and that's the last one I will ask you, is that please estimate for me the volume between 20 and 30. 20 and 30.
998.75.
Which is here, sir. Look at this. So it's 998.75. Now, what's the problem of this? Let's go on the plan view so you can see the problem. So on the table here, the software know nothing about your area. You as a user give the software where should you cut a section. You directed the software completely where you cut the section. So the software did nothing wrong. It finds a section at 0, at 10, 20, 30, and 40. Find the areas. Everything is perfect here. How about the plan view? So let's look at the plan view. Okay, the plan view is the software simply took your cross-section area, which is exactly at 20, but the problem is there is a building. So the software got this big area from here to there and get the average between this area and this area here. And what this mean? This means, it means you have demolished the building, while the reality is the building is to stay, and we need to account for that. Anyone to tell me what to do without the software steps, huh? Tell me what to do to avoid this problem here. Any suggestion on how to fix this problem? So the software, if I give them section at 20 and 30, simply they take into consideration the building. How to remove the building from the cross sections? Any thought?
We can create and I think an alignment line, like the blue lines that we have there at the edge of the building. And the long one, we can cut it short. Instead of 40, we can make it 20.
Okay, guys. So thank you so much. You're along the same line. So I think, Shimaz, you're asking for more sections. Is that right? More sections.
Yes, sir.
Okay, so Shimaz is asking, okay, you know what? Somehow the solution for this puzzle is to add some more sections. I'll show you where and I'll explain why. So I'm going to cut more sections, which is not super science. Huh? You go from menu sections, you go and say create sample lines. So as usual, please read the command line. So the command line is asking me, you want to cut sections with which reference line, with which alignment? You have two options. Either on the plan view, you pick your alignment, or the other option is hit enter on your keyboard. You hit enter, it will show you all the alignments in this drawing. You pick the alignment you wish. Luckily here we have one, hit OK. Now, the other option is I go here and I say, okay, you know what? I want to cut section at station, Now, I will give you where you should cut sections and will explain later on. You know what? My section will be 20.01. I will cut section here and I will say the station is 20.01. And remember, 20.01. It means just 1 centimeter into the building. Because look at the plan view, please. Look at the plan view, and given the size, cell size is 10 meter, so you can see this is 0, 10, 20. So I'm doing a section 20.01. It means, look at this, it means somewhere here, okay? So how much left of the alignment? Any help? For this section, how much left of the alignment? I'm gonna hit enter. The software is asking me, how much do you want to extend your section left of the alignment? Any help?
Should be 0.
Thank you, sir. 0. How much right of the alignment?
I think for this one it would be 10, wouldn't it? Because we're just going between those two.
I'm asking you, look at the reference line. Reference line is on the north. I'm asking you how far you want to extend your section from the alignment on the north to the right. Okay? I know that there will be a big fight right now because some of you will say, let's extend it to 20, because every cell is 10 meters, huh? So this is 10 meters and 10 meters. So to the building edge here is 20 meters right of the alignment. So some of you will say, make it 20. And you guys know if I ask for 40, is that a mistake? If I ask for more than I should, is that a mistake? Hello. If I ask for wider section more than I should, is that a mistake?
I don't know.
It's not a mistake, huh? So I will simply, you know what? I will ask for 50, not even 40. I will ask for 50. Again, this is only for education. When I block my section, I want all of you guys to see what's happening, huh? So I will ask for 50 meters and then hit enter. Do you see my new section? I'm going to zoom on the plan view. Here is my new section, and you can see it's even went beyond the building, the ground, and it's 1 centimeter, huh? Very, very tiny, a little bit off this kick in. Now, anybody is following to tell me, am I done? Is that only one section is required, one extra section is required, or I need to do the same thing on the other kick out? What do you think?
You'd have to do the other side as well.
Thank you, sir. So anybody to tell me where, like in terms of station, where should I cut my next section? Remember, the building goes from 20 to 30. I added one more section at 20.01, which is right immediately after the building kicks in. And then I'm asking you, what is the station of the next section?
Would it be 20.9?
29.99.
Yes.
29.99. Great, thank you. How much on the left?
0.
0.
Thank you. I want to go by the same token. I want to go to 50, please. But just, just follow me for now and you will see why I'm doing this, huh? So I'm going to go for 50. Although I can go for 40 or again go for 20, but for good reason, I will go for 40. For 50, I'm sorry. So watch this. I will click enter. So here is my other section. You know what? Those sections will do the magic. Those sections will do the magic. And I will show you shortly why those extra sections will do the magic. Those sections will simply remove the building from your calculation. Let's finish this command, okay? And let's simply plot those sections, huh? Let's come here and let's plot the sections. So I go here from menu sections, and what I will do is I will say create section view. Not why not views? Because I want to cut. I want to plot only those 2 extra sections. So I come here. Here is my alignment. Here is my sample line group. When you drop this menu right now, do we have 5 or we have 7? Can you please check me? Do we have 5 sections or 7?
7 sections.
We have 7 sections. Why is that? Because I've added 2. Look at this. I have a section at 20.01 and 29.99. So I go 20.01, and you know what? I'm happy with everything else. So right away, I don't have to do to press next. I will go right away, say create section view. And you know what? I will place it here. This is 29. Here we go. I'm going to place it here. Why I'm placing here? Because it's going to be next side by side with the 20. Okay, side by side next to the 20. I'm going to move it here. Huh? Move here. So side by side next to 20. Because I have a discussion now, I'm going to put them side by side, and I will ask you to visually examine what's happening between the 20 and 21. Remember, between those sections is only 1 centimeter. Huh? 1 centimeter. Now, the other one, I'm going to place it next to my 30. Huh? I'll come here. I'll go sections, create section view. I'll drop this menu. I will choose 29.99. And right away, I will go create section view. And I will place it here next to my 30. Okay, just like that. And you can see they are side by side. Now time to examine the secret or the magic of those sections. Please watch. Here is 20, and 1 centimeter later, it went to 20.01. Anybody can visually see the difference between the areas?
It's only showing the first like 20 meters there, and then there's no fill.
Yeah, because remember, I have removed, if I zoom in here, what is this line at the bottom? You guys remember what is the line at the bottom? This was my design surface that goes at 9, correct? And you can see I have edited my surface and I have removed this signal, this line. I will draw for you. So I'm going to go from here, from line. So you guys can see, I'll go here from this point. I'll go here, and this was my design surface. However, I have removed the building from my design surface. So this guy is removed. And you can see, since we have only one bound, do you see any area calculation here? Do you see any area calculation here? There is only one upper bound. There is no lower bound. So you can see this area, there is no area calculation, because simply there is only one upper bound. There is no design. That's why there is no area calculation. Now I'll zoom out. Watch this. Look at how big the area at 20 and how small the area at 20.01. And remember, between them, it's only 1 centimeter. 1 centimeter. Do you see the difference in cross-section area?
Yep.
Okay, we'll do the same exercise here very quickly. So here we go. This is at 29.99, where the building has been removed from the design surface, and this one at 30. Do you see the difference in cross-section area? And that was the mistake. The software is perfect software. It simply uses the area at 20. So I'm gonna draw something for you here. So the software uses this area before, not now. Between 20 and then between 30, and right away find the volume in between 20 and 30. While now I'm asking you, look at the jump. Look at the jump between the area of 20 and 20.01. It went from 95.75 meters square to 35 meters square because of the building. So you know what happens? So the software, once you added those sections, remember, where is my extra sections? I'll clean a little bit. Here we go. So erase those. And where is my extra sections? Here we go. So we have added section at 20.01, and we also have an extra section at 20.99. Those never existed before. And you can see the table updated itself by itself. I never recreate my table. My table has echo to all my changes. So I'm asking you right now, how the software will estimate the volume right now? Now, not before. The software right now will go and pick the area at 20, which is 95.75, plus the area at 20.01, which is 35. We'll get an average and then multiply it by how much? What do you think? We'll take 95.75 plus 35.01 divided by 2. So it's an average area, multiply it by the distance in between. How much the distance in between?
0.01.
Exactly, say the 0.01. And if you do the calculation, it will give you very, very little volume, 0.65. Here is the magic. I'll prove it to you by numbers. Let's put the numbers together. So now here is my total volume, which is 3,391, against two things. Against my volume dashboard and against the manual. I'm asking you, do we have good number now?
Yeah, what we have is matching the one we did manually.
Yes, sir. Okay. So guys, here is the point. So you can see those two extra sections saved your life. And now you can see my volume using the three method. They are very, very close to each other. Before, when I simply had no extra sections, simply the software, not really because the software is a bad software. Remember, you are the one who is driving the software, telling the software where to cut the sections. Okay? Are you guys following? So here is the bottom line based on all these discussions. In general, my section will go in a constant interval. Like you can see, I'm going here 0, 10, 20. However, whenever or wherever there is a sharp change, there is a kick in or kick out, there is a sharp change in my ground, then in order for the software to account for this sharp change, you must add extra sections where the ground changes. Are you guys following, or that's too difficult to understand?
I think it makes sense.
Okay, now final conclusion is I want to put everything in perspective right now. So you can see, I want you guys to understand the beauty of every method. The beauty of the volume dashboard looks like it's very simple, huh? Looks like all you have to do is build the two surfaces, edit the surface if required, then find the volume right away. Problem is, no details. How about the cross-section area method? It's a fantastic method. You can see I can give to my client right now, give all the cross sections, give them all the areas, all the volume, okay? So it's very detailed. You have evidence of your proof. And remember, those sections can be visually verified on site. So if you go to on site, you can simply verify those sections visually on site, okay? So it's very detailed, the method. However, it is sensitive to where you place your sections. So in general, what you want to do, let me ask you in general, if you are doing this on real life, any advice on what to do, how to go about estimating the volume? Anyone has a plan on how to find the volume and make sure that they got no error? Anyone follow this discussion, this lengthy, detailed discussion, and came up with a plan? If I gave you a job to find the volume, would you use only volume dashboard or only the cross section, or both of them? What do you think?
Would you use both?
That is exactly my answer, sir. I will do both. I will estimate the volume using volume dashboard, and I know the number is accurate. However, there is no details of the steps. And I will do the cross-section area. And what happens if the two numbers matches or close enough, then I know that I have done the cross-sections where it is required to be. However, if the numbers do not match, then I know right away that I have missed some of the sections. Do you guys agree or disagree?
Yeah, agree.
Okay, so this will conclude this part of the lecture today. We will break for 10 minutes. We'll come back at 11. But please, when you come back, please make sure you download a couple of things from the D2L. So on the D2L, please go to module number 3 called Curve Computation or Layout. And there are two things there. There is a PDF file for tutorial number 3, which is our last tutorial. And then for something called HC, which is a CAD file. I will do that right away. Yeah? I will download HC and AutoCAD file. And please, for you guys, download the tutorial, because this is a PDF file that tells you all the steps that we will do after the break. We'll see you guys in 10 minutes.